Today is a discussion on bagworms and Japanese beetles. These are two insects that we have a lot of questions and things happening in the landscape with each year. So right now we're still ahead of what you're going to be seeing in the upcoming months. So Dr. Cloyd will touch on that with what to look out for this year and all your questions in regards to them as he goes through his presentations. And our next seminar will be on Saturday, May 20th. It's Bees and Beekeeping with Dr. Cloyd again. And our newsletter, podcast, you can find those on the bluenursery.com website. Facebook, we post regularly. I'm going to pass around a sign up. It's just if you want to get on our email list. It also helps us with attendance, but we don't do anything else with it. And then our next event card will be coming out soon to cover June, July, and August. So we'll announce that when we get it printed and put out. And I'll turn it over to Dr. Cloyd.
Thank you, Katie. Well, I'd like to welcome everybody this morning. We are going to be talking about, this is my pointer because my other pointer doesn't work on these, but so we do have to go back to some old strategies. It's always a pleasure to give these educational programs. I am at the Kansas State. I've been there over 20 years, at the University of Illinois for 6, for adjuvants from California. My folks live in Idaho. We've had some discussions about that. But the two insects is actually bagworm and Japanese beetle. How many deal with these two? How many deal with them simultaneously? Yeah. I think one of them could be the state insect of Kansas. The other one probably is getting close. But these they're two different insects that are out there. However, they both have chewing mouth parts. They basically are, there you go, chewing insects. And we are going to go through them very diligently. And if you have any questions, raise your hand. This is all interaction. And so what I want to go through is give you an overview, introduction initially very quickly. Then we'll hit bagworm for the first half, and then Japanese beetle. Now, a couple things to get into is this insect is primarily a problem on the above ground plant parts, okay? So there's nothing in the soil. This one, though, we're going to talk about both above ground and below ground because the grubs are a problem. So we deal with the adults for a short period of time in the summer, and then we deal with the grubs, okay? So basically, and then any questions you have, there's some people that walked in. Are you here for the seminar?
Yes, we are.
Okay. So let me give you some handouts. You just came in time. 5 minutes later, you would have been too late. No, there you go.
Thank you.
And so, Katie, can you hand these out when people come in? Here. This. I'll give this to this. Here you go, sir. Okay. So let's talk about bagworms. There are many caterpillar pests we deal with normally throughout Kansas. The mimosa webworm, Genesta webworm, fall webworm. This is yellow-neck caterpillar. That's the red bud leaf folder, and this is the eastern tent caterpillar. We have a lot of these. And so when you look at caterpillar pests, we have 4 distinct categories. We have the open feeding ones, which is basically the yellow-neck caterpillar. We have the nest building ones. That includes eastern tent caterpillar, red bud leaf folder, mimosa webworm, fall webworm, okay? And also bagworm falls in that. The leaf rollers include the leaf bud, that's the red bud leaf folder. You see that how many seen that in your red buds? They fold up the leaves, you open them up, and there's a white webbing. That's what they do. Has anybody seen that on their red buds? Okay. And then we do have wood-boring caterpillars. The big one is always ash lilac borer. But when you look at bagworms or bagworm, they are a nest builder, and this is what we have. So normally you see the bag. What they do is they start feeding, they start eating, and then they basically create this encasement that protects them from predators, both vertebrate and invertebrate predators. And they don't come out very often. They only come out a little bit feed. But that's what the caterpillar looks like, and that's a female. We'll talk more about that. And then that's what you see later on in the year when they're getting into the reproductive mode and they're not feeding, okay? So this could be the state instance of Kansas. I think it's all over the, would you agree with me? I think we probably should put that to the legislator in Topeka. Let's make this. So let's talk a little, what are bagworms? Let's get a little history. They are native of North America. They feed on trees and shrubs. This is the thing about bagworms. Initially, we thought, it's only conifers. Juniper, spruce, fir, arborvitae. No, they feed on a lot more different plant material, mainly because of the suburbanization, new plants being put in there. They are very prolificous, meaning they feed on a lot of different plants. Although, so it's just not conifers, basically, overall. There's one generation per year, as we know, maybe a generation and a half, depending on what type of weather we get in November, December. They overwinter as eggs. This is critical. This is how they overwinter as eggs inside the female bags. The female never becomes a moth. Stays as a larva, goes through pupa, she lays her egg complement, and then she dies. Sometimes she falls out of the bag onto the ground. However, each bag can contain between 500 to 1,000 eggs. Okay? They normally emerge May through June, but that will be contingent on temperature. Basically, the cooler the temperature, the more delayed. If it gets hot, it'll exacerbate the development and they may come out earlier. The first instar larvae disperse by means of ballooning. What that means is when the larvae emerge from the eggs, they go to the top of a tree and they spin a tiny silken strand. And that allows them to get caught in wind, and we have lots of wind in Kansas. And that's why people in the West, I get these calls, my windbreak now is bagworms, but I haven't seen them for 20 years because they get moved around by wind currents, okay? So the male becomes a winged individual. I'll show you a picture. He mates with the female, then dies, and then the female stays in the bag. So that's really much some general background information. And we'll cover this. So this is not an exhaustive list, but this is what bagworms feed upon. So you have some conifers, spruce, maple, and broadleaves, willow, black elm, linden, oak, crabapple, rose. We've seen it feed on rose, hackberry, and honey locust. A lot of different trees Japanese beetle too, but the bagworms will feed upon. Okay. So this is on a rose taken by Chuck Gotti, former extension agent Geary County, and you can see the small bags. The caterpillars are inside these bags, and you can see some of the initial damage they do on roses. Okay. This is again the early stages that'll come out May, June, probably June. This is the susceptible stage to insecticides. This is where you want to target your sprays, is when they're that size, okay? So they're feeding on a juniper or arborvitae, and they get bigger. They're about 1/8 to 1/4 inch feeding upon, but you see they're never leaving the bag. They're always in the bag, and that's why there's not very many predators or parasitoids for bagworms, because they're protected in that encased environment, okay? So later on, they get bigger, and this is what you see. This is the thorax. They don't come out fully. The head, they feed, and they get disturbed. They'll retract back into the casement or the bag. Okay. So very hard. You never get the entire picture. They're always in the bag, basically. And so they feed on a wide diversity of plants, and you can always tell what they're feeding upon based on the encasement. This is a honey locust, and whatever they're feeding upon, that's what they make their bag out of. If it was a juniper, you would see the berries on there. If it was a fir, spruce, you would see the needles on the outside of the bag. Okay. This is what they can do. This is an arborvitae, and this is the damage done by bagworms. Okay. This is why you have to manage them. Like how many have had this happen in your yard? A few of you. So the rest of you are doing good. The bagworms aren't a problem, right? Okay, that's the problem. You don't do anything else, and this is what happens in juniper. This is a collaborator I work with in about the Edgerton area, and you can see there is nothing left on the juniper. Now, the question we get is, well, will that kill it? It's not very pretty, but if you get continual years of defoliation, 2 to 3 years, it will set the plant back where it's no longer aesthetically appealing, and it might be susceptible to secondary pathogens or secondary insects like wood-boring insects. Okay, so you have to do something. And then this is 2018 was disastrous for bagworms. This is a tree that's been absolutely defoliated. This is the onset. You can see the browning. That's where the bagworms are feeding. This is actually in Manhattan near my house on Candlewood Boulevard in the corner there of Candlewood, and I think it's Woods Street, basically. And I think like 1,000 bagworms were on that tree. It was absolutely wonderful from an entomological perspective, but not from the homeowner perspective. Just I have to make that distinction, okay? How many saw this level of 2018 was one of the worst years we've ever had for bagworms. Okay? This is what happens this is my yard. My wife didn't quite like it, but I did get one rep. This is a thuja, was a thuja, and that died right after that. Now remember, conifers don't put out new growth after they've lost their foliage. Okay? They don't, like broadleaves will. So that plant died. I couldn't do any more replications, but if you do not manage bagworms, that is the consequences. Okay? That's what they can do. So this is later on in the season. This is what we'll probably see about August, September, probably or October, is eventually they form a cap. We call it the green or brown cap stage, and they're no longer feeding. Okay, the males will be transformed into females. I mean, the males will be the caterpillars genetically set to be males will become winged individuals, and the females will stay as caterpillars. But it's too late to do anything other than hand removal, which I showed you. Sprays will not work at this point. Okay, but remember, each female bag has between 500 to 1,000 eggs. So if you opened up a bag, has anybody tried to open up one of those bags? They ought to make airplanes out of that stuff. It is tough, very tough to open up. But if you open up a female bag, this is what the female looks like. She's turning into a pupal stage, and if you cut a body cavity open, that's where the eggs are at. That's the 500 to 1,000 eggs that are inside her body. Once those eggs, the larvae emerge, then she basically drops down into the soil overall. And there's a really great publication. It's old, but it's great. And I think I have to give credit to the Kansas State Interlibrary Loans for this. Bagworm moths of Western Hemisphere, 1964. But look at that. It's chock full of good information. I mean, and there's really good information that still is relevant today, okay? So, what you look for is bags that have these papery cases are males, no eggs. That's where the male transitions into an adult moth. So, hand-picking those is not going to do anything because there's no eggs in them, okay? And so what I'll show you is a Riker mount, pass this around. This is the male bags, and the image is the male bagworm adult. Becomes a black moth. The female gives off pheromones that lures the moth, the male. He gets into the bag with the female, mates, he dies, and then she basically at that point is set to lay her complement of between 500 and 1,000 eggs, and then after she does that, she dies. Okay, so that's why there's one generation per year. Okay, so whenever you see those brown papery cases, that is where the males emerge, and there are no eggs in those bags. There's what the male looks like. That's a close-up. Okay, he hones in on the pheromones. That's why males typically have fuzzy filamentous antenna, mates with the female, and then probably dies within several hours after mating. Okay. Now, bagworms are found a lot of places people don't expect. Side of a house. What are they feeding on? You know. So this is on my house, so they're probably residing there. Chicken wire. I didn't know chicken wire was a food source for them, but they're up there eating on the chicken wire. And this is on a window, and actually they're eating the paint. Bagworms will actually, if they're really hungry, they'll actually eat the bag they're in partly, but they're actually eating the paint on the side of a house here that I was called on. So they're very, very prolificous, feeding on not just plants, but other material that's out there, okay? One of the recommendations is hand removal. How many try to hand remove them? Yeah? It's great therapy. You go out, psychologically pleasing, and it can be effective, okay, in most cases. So, but what you want to remove is the female bags, and you can leave the male bags because there are no eggs there, okay? So if you squeeze, there's what they look like, and if you squeeze a little harder, you get the goo. And we've been promoting bagworm paintball events for kids. Have them get out there, squirt each other with the goo, and it's safer. It's actually it's psychologically pleasing. It's constructive. Get them outside, get them away from the devices, and it's a lot of fun. And they can just take a shower or wash it off when they're done. And you're doing a service by killing all the female bagworms. Okay, that's one option we have.
So you're supposed to do that in order to get rid of the female? You just don't take it and throw it in the garbage?
No, you do not. How many tried that? Because if they put them in your tote, your garage will be full of bagworms the next morning. Yeah, you have to kill them, and I'll show you about that. Yes, ma'am.
So if I hit them off of the house with the sprayer, they won't die on the ground. You have to actually.
You mean with like a high pressure water spray?
Right.
No, you have to kill them in the bag, and I'll show you how we do that. Yeah, you just can't pick them off, put them in a bucket or your tote. They have to be killed. Okay. Yeah. Yes, ma'am.
As I pull the bag off, I squash it. Will that kill the egg then? I mean, it's usually as soon as I see them, because I've seen the tiny ones, I've seen the bigger ones, but the bigger ones are ones I'm more concerned with because those are the ones that have the eggs probably.
Well, the females will, yeah.
Yes.
Yeah, you can squish them, step on them, as long as you do a good job.
Right.
But really, I'll show you the best method how to kill them.
Okay.
Really, we'll get to that point, okay? So this is an example of, bagworms are bringing people together. They're enhancing the quality of life. And so we have these people have these bagworm weekend hand removal gatherings. And there are no electronics allowed. They basically put all the bagworm bags they've collected, and they burn them up and they talk. How many bagworms did you collect? Oh, about 70, and this gentleman picked about 200. Bagworms are bringing people back together. So there's a lot of, so bagworms are a benefit to the quality of life, okay? So there I am in my yard. If you're going to walk the walk, talk the talk, you got to do it. So there you see these junipers, and my daughter was helping, but there you can see that getting the bags. And, well, what do I do with them? Okay, well, what you do is you get a bucket, about 1 to 10 solution of soapy water. Get some soapy water. You throw the bagworms in there. They don't like that. They get irritated. And then they come out and you put them in an area full sun and they will be killed. That's how you do it. Yeah. So about soapy water, let them sit there for about 15 minutes. Put them in an area with full sun and that will kill them. Okay? That's how we do it.
How long does that take to kill them?
On a nice sunny day, they'll be dead in a day. But the soap also irritates them and can kill them too. Some people, actually, what they'll do is they'll add a little pyrethroid-based insecticide, a pyrethroid insecticide in there, and that will also directly kill them. Okay, but you got to be careful handling it. Wear gloves because it is an insecticide, and we'll talk about those when we talk about Japanese beetles. Okay, so that's any questions?
So just water alone won't kill them?
No, nope. Water will not drown them. You have to add like a soap, or you can add an insecticide, pyrethroid base, we'll talk about those, to kill them, because if you don't kill them, the larvae will emerge from the eggs, and you're going to have these young larvae around the area. Yeah. Any other questions so far? Make sense? Okay, so what about using insecticides? There are 3 concepts I talk about, and that's timing, coverage, and frequency. The timing is when the bagworms are about 1/4 to 1/8 of an inch in size. Once they get over 1 inch, then it's really going to be too late, especially with the materials we'll talk about. You have to cover all plant parts, especially the leaves and the stems, to get contact, especially with the stomach poisons we'll talk about. Frequency. The frequency is on the label, but we generally recommend about once a week, and generally it's about 4 times once a week for about 4 weeks in general. To deal with bagworms, okay? So this is a great image I like because it talks about when you use insecticides and when you don't. So you use them in the early larval stages when I've already talked about when they're about 1/4 inch to 1/8 of an inch in size, okay? Once they get larger or pupa or adults, insecticides are extremely ineffective at that stage, okay? Okay? So this is the publication, and I know that Katie has some, but if you want the real McCoy, these are the hard copies here. You can come up and get them. But in this publication, which I developed 2 or 3 years ago, this is the terminology. The bags, when they're 8 to 1/4 inches in size, the smaller the better. Your insecticides are going to be much more effective on the smaller caterpillars, bagworms, than they are the larger ones, okay? And the eggs, the larvae do not all hatch simultaneously from those eggs. They can emerge over a several week period. That's why you have to make more than one spray in most cases to kill those larvae that emerge after you made your spray application. This can go on primarily, could be 4 weeks, depending on the number of bagworms you're dealing with in your area, okay? Any questions on that? And that is in the extension publication that you have. So this is, again, when they're an 1/8 to 1/4 inch, easy to kill. It doesn't take much active material, active ingredient to kill the bagworm larva at that point, especially with these stomach poisons, which I'll talk about.
Will malathion work on it?
Malathion will work, but malathion kills everything. Yeah, malathion, orthine, those are broad spectrum insecticides, but they kill beneficial insects and mites and bees. Yeah, but it will work, yeah. So at this point, it's too late. This is that brown or green cap stage. They're inside. The males will transition into a winged adult. The females basically is getting ready for reproduction. So there's really no feeding taking place. Consequently, that minimizes their exposure to the commonly used insecticides. Speaking of, here they are. Now this is the active ingredient. This is the trade name, common trade names. Malathion is a relative of acephate. They're both organophosphates, nerve poisons. But you can see a long list. 7 is used, although 7, carbaryl is being phased out. There's a new active being put in there. We'll talk about that. The 2 products that I recommend early on, when they are an 1/8 to 1/4 inch in size, is either Dipel or BTK, and if you're from Wichita, I know that means something else, but I apologize. That's good. And then spinosad. These are stomach poisons, which means they have to eat it. It's not so that's why you get them when they're young. These are stomach poisons. They have to eat the active ingredient, okay? And here's one of the pyrethroids. This is a material you could put in the bucket with the water to kill the larva, okay? Just make sure you wear rubber gloves because it is a contact insecticide. Okay. So this is a commercial formulation of Dipel or BTK. It's a bacteria. It's a soil-borne bacteria, and all bacteria have to be eaten by the insect. Here is a homeowner formulation. They're not worms; they're caterpillars. But there's the active ingredient: Bacillus thuringiensis, subspecies Kurostaki. That is the most selective insecticide. It only kills caterpillars. So it kills bagworm caterpillars, fall webworm caterpillar, eastern tint caterpillar. If you get monarch butterflies, and this drifts on to milkweed plants, you can kill monarch butterfly larvae, caterpillars, okay? But very, very selective. How does it work? Well, when you spray a spore, the bacterial spore, it gets on the leaf and the caterpillar eats it. And then once inside the stomach, it's converted into a protoxin, and that protoxin will bind to the gut lining, which we call in entomology epithelial, create pores, and the blood contents flow into the stomach, and they die of septicemia. It takes about 24 to 48 hours to stop feeding, but about 2 to 4 days to die because they're starving to death, basically. Now, this material will never kill humans, and the reason is because the pH, does everybody know what pH stands for? What is pH? Yeah, it's potential hydrogen or hydroxide. It's a scale from 0 to 14. 7 is neutral. Above 7 is what? No, alkaline. Below 7 is acidic. The pH of a caterpillar stomach is about 7 to 8. It's alkaline. What's the pH of a human stomach?
2.
Close, 3.5, hydrochloric acid. So the spore will never be converted into a protoxin in a human stomach. So you could eat this stuff. I've had college professors eat some, go to the bathroom, but they come back alive. So this is, again, the selectivity of this material is based on the pH of the caterpillar's stomach, okay?
That's why you can use it like on tomato plants. Like that.
Yeah, you can. And for tomato hornworm or some of the others, it will only kill the caterpillar and nothing else. No impact on bees, no impact on beneficial insects or mites, yeah. Okay? So you make applications of BT when they're young and actively feeding because they don't have to eat as much material and it quickly kills them, okay? I've used BT, and if you time it correctly, you can get really high mortality, minimize the feeding. Okay. The product that I like to work with, though, because I worked with it when it was a numbered compound in the 80s and 90s, is spinosad. Does anybody use spinosad? It is. I'm very fond of it because of the fact I worked with the company at that point. It was Dow AgroSciences, or Dow, but this is another stomach poison. They have to eat it, not as much, but it works on caterpillars, thrips, and leaf miners. But it's really good on caterpillars overall. Okay, so we have two, but remember these are stomach poisons. So when the caterpillars get larger, they're not going to work. Okay, that's why you get them when they're young. So this is when you start using pyrethroids like cyfluthrin when they're larger. However, these are going to kill natural enemies, beneficial insects and mites and bees if you get contact on them. Okay, so timing, like I said, timing is really important. Does that make sense? Any questions on that? Okay, good. So I always get the question is, what about a preventative systemic? Can I apply something to my plants preventatively to not deal with bagworms? And the answer is really no. There are some studies out there. Came off of a website, but some colleagues of mine did some work. It's not the most robust study, but they did look at some systemics, and some of them did have activity. Chloronitropenol, I'll talk about for Japanese beetle, and chloronitropenol is the active ingredient in some of the products out there. It's safe on bees. It has minimal impact on bees, and that's why people like to use it. But there's a lot of questions is on a conifer, are the bagworms eating enough of the active to kill them? And so there's a lot of studies that need to be followed up relating to that. So there are companies out there that have, this is a company that has a product called Lepitech, and that's orthene or acephate. And acephate is a true systemic, and they do have bagworms on the label along with product and application timing. Okay, so my recommendations, we really don't have systemics available that I can recommend with confidence. We still need to do some research. So really it boils down to contacts and stomach poisons, and timing of application is critical. This worked great. However, you're going to harm your trees. Sorry about that. But boy, psychologically satisfying. You know you killed all your bagworms. So a really extreme method of dealing with bagworms. I know people have thought about this. There are some laws about fires and stuff like that, but it will kill the bagworms. It kills everything, unfortunately. So here's the extension publication, 2019. It's got 4 years now. Out there has all the information. I have hard copies. Kate's got some copies that were off the website. So are there any questions about bagworms at this point? Does this all make sense? Yes, ma'am.
I have a question about budworm.
Tobacco budworm?
No, like the budworm on your petunias.
Yeah, tobacco budworm.
Oh, okay.
Yeah, that's the true name. Yeah, on petunias.
Do they
Yeah.
have a season? Or they're just awesome?
Tobacco budworm is a caterpillar. It has other names. It has I think it has 2 generations per year, maybe more, feeding on the buds of geranium and petunia. Yeah. Yeah, and so for tobacco budworm, you can use dipel or spinosad, but you have to use it before they tunnel into the bud. If you miss that opportunity, then you can't control them because they're inside the bud feeding and they escape exposure from insecticides. Yeah. Any other questions about bagworms? So nobody's gonna have any problems this year, right? You're gonna take care of bagworms. Yeah. Oh, there's yeah.
Yeah, if you don't wanna hurt any caterpillars, 'cause I love that tomato one turns into
A sphinx moth.
yeah, it looks like a hummingbird.
Yeah, they're very large, gray, they're very beautiful looking moths, yeah.
Cool.
Yeah.
And I don't wanna kill any caterpillars, what would you use if you don't wanna hurt anything?
You mean a spray?
Well, anything, powder, spray,
I don't like powder. Hand picking. I mean, most of your materials out there are going to have maybe negatively impact caterpillars. Yeah.
so just forget the,
I would probably not do spraying if you're worried about caterpillars, like the beneficial ones, like parsley worm, monarch butterfly caterpillars. I would probably stay away from most materials out there. Yeah. Yeah, Katie?
When should we start looking for activity on bagworms? Since you've been talking about bagworms first, like Is it still like late May, early June, or is the timing different this year with the weather patterns?
Everything for insects and most living organisms are going to be weather contingent. If the weather it gets warmer, we might be dealing with them in mid-May. If it's delayed, it could. But generally, the timing is about late May to mid-June. In most cases, that's a broad window. And like I said, if you get them when they're young, like like last year, I made one spray of spinosad and I had no bagworms the rest of the year because I timed it, got good coverage on I have thuya, some arborvitaes and junipers, which I showed you in that image. I only made one spray. Some people have to make more than that because they're getting them balloon, especially if they're ballooning in from another area. That's when you also have to watch out and make multiple sprays. Yeah. Yes, ma'am.
How do you determine if you spray more than once?
Well, when
Just keep watching?
you keep watching. If you're not seeing any damage or movement, you've killed them. Yeah, because they will stay on the plant in most cases, even if you spray them and they're killed. But if you're not seeing any damage, progressive damage, then you probably have killed them. Yeah,
Okay.
yeah. Any other questions about bagworms? Okay, if you have some, you have some more. So I think now we move into, well, I get a Japanese beetle. How many deal with Japanese beetles? Okay, another stage. So again, the first part we'll talk about the adults. And then after that, we'll talk about the larval stage. So Japanese beetle is a very beautiful insect. It's metallic green. And of course, the way you tell Japanese beetle from all other scarabs or these types is they have about 10 to 14 white tufts of hair around the abdomen. That's no other insect has that. Basically, they're native of Japan, so they're an invasive species. They arrived in 1916 in Riverton, New Jersey. The adults are present about June through August. Okay, so that's the adults, very short time period. They feed on over 300 plant species. The adults are about a third to half an inch, and they have white tufts of hair on the periphery of the abdomen, which I just showed you. Okay, the adults feed on leaves, flowers, and fruit. They will feed on pear, nectarines, peaches, and apples. I deal with the fruit tree growers and vegetable growers, and Japanese beetles can be extremely decimating on the fruit. Okay, they live about 30 to 45 days, so they're not out for a long period of time as adults, and they're very active on warm days, and the way they feed results in the plants having this skeletonized appearance, which I'll show you on many plants. Okay, so the life cycle. Here we are in May, they're pupating, so we have the adult stage around June through August, September, and the larval stage through most of the rest of the year. That's why they're a turf grass pest. They are a key turf grass pest, and we'll talk about how to deal with them in the larval stage after we're done dealing with them in the adult stage. Okay? So, when you're out for 3 months, I love insects because they're awfully efficient. You have two things on your mind, sex and food, and most of the time simultaneously. So here they're getting down to business. This is what we call, it's not an orgy, but it's a congregation of males mating with a female. And I like this image because you have two of the males holding on to each other right there so one doesn't fall off. And it's quite a sight when they come out early and they start wanting to mate with the females, okay? The females, after mating, will then lay her eggs into turf grass. And so with the lack of rain, that will impact egg laying. The Japanese beetle females only lay eggs when the moisture content's over 10 to 20%. If it's too dry, they will not lay eggs in there. Okay, and we'll come back to that when we talk about the larval, dealing with the larval stage. So they feed on a wide diversity of plants, just like bagworms do. Anything in the Rosaceae family, roses, pears, cherry, plum, apples, that is their favorite, although they feed on grapes, Virginia creeper, Tilia cordata, little leaf linden is extremely susceptible. Last year at Rocky Ford, where I have research plots, they were there and they just basically defoliated all the little leaf lindens on Rocky Ford. Okay, it gets pretty bad. Anything else? Am I missing one? I mean, again, this is not the 300, but this is an example of the potential plants that are susceptible to Japanese beetle feeding. Yeah.
Last year they ate all my roses there.
Yeah, hibiscus. Mm-hmm. They'll feed on it. I go out to the Manhattan Community Gardens, both the one off of Collins Road and the other one. I help Chuck Marr give advice about insects, and I've seen them feeding on asparagus. I've seen some on there's grapevines in that area. They will feed on corn. They will feed on it when it's tasseling. So yeah, a wide diversity of ornamental and vegetable crops. Okay. So that's what they'll do to tilia. And this is again that skeletonization. They don't feed on all the veins. They feed on in between veins because it's easier for their mouth parts. Okay, easier for them to feed upon. Okay, and this is what they'll do to roses. This is the initial damage. You'll see the skeletonization occurring, again, feeding in between the veins because it's easier for them to feed upon. And how bad can it get? That's how bad it can get. That's not very attractive, is it? Okay, that's the foliage. But also they feed on the flowers. And this is one of my favorite images. That's Japanese beetle feeding on the rose flower. How many have seen that? Not very attractive. Okay, rosarians do not like to see that. Okay, and I give lots of talks to the rose growers. And then that's the damage. That's not a rose you're going to show at a rose place. Okay, that's not. So they destroy the aesthetic quality of the plant by eating the foliage and also by feeding on the flowers. So every time a Japanese beetle feeds, the rose plant gives off volatiles that lure other Japanese beetle. And in addition, the Japanese beetles release an aggregation pheromone that brings in more Japanese beetles. So the plant is inundated by this continual onslaught of Japanese beetles coming in because of the chemicals released by the rose plant and also by the Japanese beetle adults. Okay. So what about management of Japanese beetle? Well, there's scouting. Some weeds like jopai weed is very attractive to Japanese beetle. Trapping, we'll talk about how inefficient that is. Hand removal and insecticides. Okay, so we'll go over each one of these. So these, how many use these? Good. They should be illegal because they actually will draw more Japanese beetles in than you'll ever see in your lifetime. And a couple things to remember. The Japanese beetles will feed before they get to the trap. The females will lay eggs in the turf grass if it's irrigated before they get into the trap. And so I wanted to show you this as a Ricoma. This is what they'll do to Tilia cordata. Okay, that's how bad it can get. So studies have shown the Japanese beetle traps can result in more damage, higher numbers of Japanese beetles, adults, potential more grub problems than if you don't use them. Okay, so and remember, these are not killing the Japanese beetles; they're just attracting them to the area. Okay, so you will see these smothered in live Japanese beetles, but they're still alive. Okay, so what's there? Well, the Japanese beetle trap has a lure for the male and a pheromone lure for the male and a floral lure for the female. So you're attracting both sexes to these Japanese beetle traps. Okay. So here's beetle bagger. Now what's really interesting is eugeniol and geraniol. Those are two volatile compounds that are emitted by rose leaves when they're attacked by Japanese beetles. So they're using the natural plant volatiles in these products. This is for the female. The sex pheromone is for the male, and that's a synthetically derived compound that they develop in lab, and that draws the adult male to these traps. Okay, but they should not. What we recommend, extension-wise, give these to your neighbors as Christmas presents. That's what you want to do. Okay, so you will get lots of Japanese beetles. Here's a trap there. There is the pheromone, and there's the lure, and you'll get lots of them. But remember, Japanese beetles can fly 4 to 5 miles. Okay, so you're bringing them in from large distances. Here's a trap, and here's the jar, and there's supposed to be a contest. How many Japanese beetle adults are in here? Okay, we'll go that route. That trap was out 2 years. That's the catch after the second year. So those traps can last more than 1 year, and that's how many you can get. This is in a working with the fruit tree grower up in the Sabetha area, northeastern Kansas I work with, and they were using this away from the area to lure the Japanese beetles away from the fruit trees, apples, peaches, pears, nectarines, things like that. But they were catching lots of Japanese beetles in these traps, even 2 years after they were put out. So, Science. I'm a scientist. I look for evidence and data. Colleagues, Kentucky. Use of a single Japanese beetle traps or small-scale multiple trap arrangements will not prevent or reduce defoliation of nearby plantings and will probably increase the damage inflicted, highly preferred and less attractive. How's that? Number one, the Japanese beetle adults will feed before they get to the trap. Number two, it doesn't kill them. And number three, if you're irrigating the turf grass, the females can lay her eggs into the turf grass. Consequently, you might have more problems with grubs that year. Okay? So those are the reasons we do not recommend the Japanese beetle traps. Any questions on that? Concerns? Comments? Does that make sense? Okay. This is a publication called Roses Without Chemicals, and it talks about some control measures. Well, natural repellents, catnip, chives, garlic, tansy, they don't work. Okay. That's not the way to. Using parasitic wasps, beneficial insects, they don't kill enough Japanese beetles. Okay? Birds. Birds will eat them, but they don't eat enough to impact the populations. It's a numbers game. They have to eat enough of these insects to impact their populations to minimize plant damage. Milky spore, that's for the larvae. That's for the grubs. However, it is a bacteria, and it doesn't do well in our environment, especially when we don't get a lot of rain. The last comment is traps. Beetle traps do attract Japanese beetles, however, they work too well. And again, they're talking exactly what I said. Okay, they probably would lead to more problems with Japanese beetles than if you didn't use the traps. Okay, so there's number one, like bagworm, there's hand removal. You can be out there, and there was a great study that showed if you're out there 3 times per day for 4 weeks, you can impact the populations. Well, being out there 3 times a day, I don't have that kind of time. So, but that's one of the studies that was out there. You pick them off, put them in a bucket of soapy water, just like bagworms, and that will kill them. The soapy water here will kill the Japanese beetle adults, unlike bagworms where it won't kill them. Okay?
So your soapy water is just detergent, like Usporin?
Yeah, Dawn, palm olive, some soapy water material. Or you can use potassium salts of fatty acids, which is a insecticide, and mix that in there, and that'll also kill them. Yeah.
What about a little bit of salt?
What's that?
What about a little bit of salt?
No, salt won't have any effect. No. So soapy water or a potassium salts of fatty acids, which is an insecticidal soap, you can mix into a bucket. Yeah.
How long do you leave them in that?
Oh, you probably leave them like 15 minutes and they would be dead.
Okay.
Yeah. Similar to bagworms. Yeah.
Yeah.
So the problem we deal with today is that the main way of dealing with Japanese beetles is pesticides. And as an entomologist, I get a little disconcerting that we really haven't made much progress in the last 50 to 60 years dealing with Japanese beetles with selective insecticides or non-chemical means. It still relies on what we call these broad spectrum materials that are out there, and basically this is what you got. But first of all, you have to spray when the adults are present. There is no preventative systemic for Japanese beetles that I would recommend, okay? And then the problem with these is that many of these are broad spectrum. That means they kill everything, beneficial insects, mites, and bees. And if you use these too often, you will stimulate outbreaks of the two-spotted spider mite. I get these calls every year. Why are my euonymus bushes losing their leaves in summertime? Well, I say, did you use an insecticide? Yeah. Carbaryl. How often do you spray? 3 times a week. There you did. You've just basically disrupted the ecosystem, and now there are no natural enemies out there for spider mites, and you're dealing with another pest problem. Okay? We'll talk more about that. This is what you got. Acephate, these are all broad spectrum material. Now, this works really good, but you'll kill your roses too. Okay, plants. But really, see, all these are either organophosphates, carbamates, or pyrethroids. Those are chemical classes, and we don't really have any selective materials out there like we do for bagworms. There's no spinosad or dipel for Japanese beetles. It's all broad spectrum, and so these materials, yes, they will kill Japanese beetles, but they're going to disrupt the environment, the ecosystem, because they're killing everything that's there. Okay? So here's an example of rose and flower killer. It has cyfluthrin, that one, and imidacloprid, which is that one. It has 2 materials there. And on the back of the label, it says, this pesticide is highly toxic to bees. Do not apply when bees are active. But it's clear as mud right there. That's exactly true, okay? Now, this is a product out there. I call it the Sam's Club of pesticides because it has a fungicide, a fertilizer, and 2 insecticides. It does have Japanese beetles on there as a systemic. But as I was talking to the nice lady here, is remember the Japanese beetle adult still has to feed in the plant to ingest a lethal concentration of the active ingredient. So the plant will be given off volatiles that'll lure more Japanese beetles. So I do not recommend systemics because of that consequence. The unintended consequences being, yes, you can apply it, but the Japanese beetle adults still have to ingest a lethal concentration and they still have to feed in the plant. Okay? So if you've got 50 Japanese beetles out there still feeding on your rose plant, they can still cause damage. Okay?
So it isn't like you would spray, like with this stuff over here, the advanced stuff, after you take off all the beetles, like leave the beetles on there, then spray, is that what you're saying?
Right. The question is, the beetles have to be there to spray with them. All these materials are contact.
So, but then other beetles that come, they won't be as attracted because you don't have the, yes.
So that's a good question. So if you spray Monday, you spray your roses or your tillias, and you kill most of the Japanese beetles, they drop. Well, other Japanese beetles can still feed on the plant because it's given off volatiles. Then you got to go out there and spray again. I remember in Illinois when I was there for 6 years, we had people spraying 3 times a week, and basically that's why they were having spider mite problems and problems with other pests, because they were killing the natural enemies or beneficial insects of those other pests.
So then what is the formula? Like you would just spray one time for the week, and then if you go, if they come back, I've seen this happen with mine.
Yeah.
So then pick off a couple, then try to keep picking them off until another week.
Right.
Do it again.
And then do it. Yeah. And,
Okay.
but we'll talk about the consequences of spraying too often. Okay. But that's a great question. So basically, that's the only maybe systemic. 7 is still the most widely used. Now remember, 7, the active ingredient is carbaryl. That material is being phased out. The new active ingredient in most carbaryl formulations is zeta-cypermethrin. That's the new active in 7 now, okay? Or there's some other pyrethroids overall. But carbaryl, being an old carbamate is being phased out, okay? So it's still widely used. It's cheap, effective, kills everything, and it's unfortunately formulated as a dust. Dust is the worst formulation because you don't get good coverage. Winds moves it around and things like that. So, this is sort of you have to spray basically or do something, or your roses are going to look like some of the pictures I showed you. So, what is the ecological impact of using these broad spectrum materials? And the term we use is called secondary pest outbreak. If you continue to spray with these broad spectrum materials, you're going to stimulate outbreaks of other pests. Well, how does this work? Well, for example, let's just say you're going along and, what's your name, sir?
Jason.
Jason sprays Japanese beetles on his, let's just say roses, with malathion. Okay. Well, he drops the Japanese beetles, but what happens is the 2-spotted spider mite populations were being suppressed or regulated by natural enemies, beneficial mites that are out there. So when Jason sprayed, he killed Japanese beetles, but he also killed the good insects and mites, and now 2-spotted spider mite becomes his primary pest. This is what secondary pest outbreak is you're replacing your primary pest with another pest. And so this situation right here is called a pesticide treadmill. You have to spray now. Okay? Has anybody had this happen to you? It happens I get the calls in summer, a lot of calls relating to this. Yeah.
Do you
Okay.
use the same insecticide to get rid center of the mite center, a different insecticide?
You would have to use a miticide,
Miticide.
something else that will kill the mites. Yeah. Okay, so this also works for Japanese beetles, not just bagworms. So it's a very broad spectrum, very effective against both these pests. Okay. However, you're not going to have many plants left over, Andrew. So yeah. Okay. So so here is the extension publication, and I brought hard copies of the one that Katie kindly printed off. Are there any questions about the adult management of Japanese beetles? Okay. Now, let's go back to the life cycle. We covered this one. Let's talk about how to deal with the grubs. Okay. Well, they are in the turf grass. Those are Japanese beetle grubs. C-shaped. They're C-shaped because they don't like the sunlight, and they feed on turf grass. They feed on turf grass early on, but they're most damaging in August, September when it's hot and dry and the turf grass is stressed. Okay. So what we recommend is about 2 to 3 months before the larvae emerge from the eggs, or 4 to 6 weeks, you apply your insecticide. Okay. Well, let's look at that. Okay. So here's the life cycle. About May to June is when you should apply an insecticide, get that residue there, so when the female lays her eggs and the young larvae emerge from the grubs, they come in contact with the residues and are killed. If you miss that opportunity, then you've got large third instar grubs to deal with. Okay? So, what's available? So these are the active ingredients of the materials you would apply before the female lays her eggs. Imidacloprid's been used a long time, but this is the newest one. And the reason why that's available is because it's softer on beneficials. It's less harmful to pollinators than imidacloprid is. Now, let's just say, for example, you miss this opportunity and you're dealing with third instar grubs. What do I do? Well, you can use Dilox. Dilox is, hey, Dustin, our rescue treatment. The problem is it only lasts about 2 to 3 days, but it will kill large grubs in the turf. Okay? So if you miss this opportunity, then you've got Dilox. Okay? And you may have to make more than one application depending on the density of the grubs in the turf grass. Okay? Any questions on that? Yes, ma'am.
How do you judge the competency of what you did?
Great question. How do you know? Okay, one indirect way is if you don't see much damage. But what we like to do is tell people to go out there in the turf and cut a C-shaped, peel it back, and look for grubs if they're alive or dead. That's what I do. That's what I do in my turf grass plots. It's on the 11th year. That's what I do in Rocky Ford, monitor turf grass plots for the densities and the abundance of different grubs that are out there in those plots. Okay, that's what you need to do. Or hire a company to do that for you. But that's how you quantitatively assess if the materials are working or not. Okay? Great question. So, this is chlornitrophenol. This is GrubX. This is one of the formulations. And again, GrubX has several benefits. Number one, it's safer around pollinators. Studies have shown that. Number two, not only does it kill grubs, but it's active on the caterpillars that attack turf grass like buffalo grass webworm, fall armyworm, cutworm, things like that. Imidacloprid will not kill caterpillars. It only works on grubs in the turf grass. Okay? So chlornitrophenol gives you a broader spectrum of activity. And here's the newest product that came out 2 years ago, Roundup. It's got chlornitrophenol, but also bifenthrin. That's probably for the caterpillars. But this is a product that Home Depot and some others have sold, and it's widely available.
And that's a good one?
Chlornitrophenol is less toxic to pollinators and earthworms. Imidacloprid is toxic to earthworms. Okay? So there's less indirect harmful effect on some of the other arthropods or flora that's in the soil.
So would you use that Roundup in that May, June timeframe, or if you missed?
Yes. Now, this is the thing about using those products is if the caterpillar pests are normally prevalent here, well, if you apply too early, you're not going to get the grubs. You'll get the caterpillars, but not the grubs. So you want to try to apply it about late May, early June,
Okay.
if you're targeting the grubs.
But if you miss that time frame, you're still use that, or do you use the bio-advanced grub killer?
If you miss this opportunity in dealing with this, then you got to use Dialox.
And that's, yeah.
Yeah.
Okay. That's,
This is the bag of yeah.
Gotcha.
That's the beer advance. Any questions? Oh yeah, Katie.
Okay, so with the calendar in late May, early June, you're saying to put dialogues down at that time, or would you use imidacloprid, just trying to stop Japanese beetle stuff?
Okay, so at this window right here, you're going to use these 4. If you miss that window, if you miss this window and dealing here, then you're dealing with Dialox.
What if they are trying to treat their lawn for grubs? They're usually putting down imidacloprid in June, but if it's too late, would they still need to use Dialox later if they're...
They could. Yep. Even if you did apply imidacloprid and you didn't get 100% mortality, which doesn't happen, and you are dealing with third N-star grubs, you still have to apply Dialox. You're probably going to have to apply Dialox. Yeah. That makes sense?
and that's used with a spreader? Is that used with a spreader?
It's a granular, so it's used with a spreader. Yeah.
And then
Yeah.
you work it in? Or
You
no?
water it in.
Water it in.
Remember, when you apply it, you got to water it in because you want that active in the top 1 to 2 inches of the soil. That's where the larva will be residing after they've emerged from the eggs.
So do you think in a big pot like this, soil, do you think those would be in there?
You'd have to you'd have to check it, see if grubs are in there. Yeah. Yes, sir. Okay. The question is, what's the best time to put? What's the best time to put this product on? Right in that window, right there. Okay. What's that?
We don't carry the Scott's brand or the Roundup
Oh.
product, but we have the imidacloprid or the Dialox.
Yeah, yeah. Okay, so these are commercial. This one is commercially limited. This one probably not to the homeowner. The professionals will have it. This is available but limited. So the materials that you have available at most of the garden centers and box stores are imidacloprid, this one, and then trichlorphan. Those are the main 3. Yeah, that I've seen in the trade when I'm out there looking at products. Okay. Great. Any other questions about that? Yeah.
So if you're just gonna go out and live your mom yourself, how many days do you go out every day between June and August, or? So they're staying.
Oh, so picking off Japanese beetle adults? Yeah, the question was how often you do that. You probably have to do it every day.
Yeah.
Every day. Yeah.
I tried that bag thing last year, and I swear I had millions of them in these. They just fill these bags, but they kept coming.
Oh, yeah.
And I finally gave up.
Yeah. That's why we don't recommend them except for Christmas presents to your neighbors. Yeah. That's what we do. Yeah.
Very good, thank you.
You're welcome. So, okay, so here's Dialox. This is the bag right here. That's the material you will use when you're dealing with the large grubs. Again, it kills them very fast, but it only lasts about 2 to 3 days. So you may have to come back and do it again if you assess that the grubs are still present, causing damage to your turf grass. Yeah. I do have this publication, and I'll leave some copies. This is dealing with the grub stage of Japanese and other grubs, southern mass chafer, northern mass chafer, May beetle, June beetle, things like that. So this is another, so we've talked about the above ground life stage and now the below ground life stage, and we have extension publications to cover both of those. Okay, so I do thank you for attention. Thanks for showing up this morning, and that's all I have. And are there any questions? So thank you very much. Yeah, Katie?
I have 2 scenarios that have happened in the last couple of years more often, where the Japanese beetles are hovering around plants, like they just had come out, and they're hovering around plants, and homeowners don't know what to do, if they're supposed to start spraying their plants, or how do they deal with them. And then the other scenario that's been happening more is people have produce on their fruit trees, and the Japanese beetles are starting to eat the produce, but they can't harvest it yet, and they're struggling with how to save their produce. So do you have any suggestions for either?
Okay, so the first question is in the insect world, the males come out first. They'll hover around the turf, waiting for the females to come out, and then they'll mate. And then that's how that happens. So when you start seeing adults out there, be ready to spray if they're on your plants. Okay, but don't go out there and do a blanket application. Okay, on fruits like apples and peaches and nectarines and those, you got to pick them off. It's the only thing you can do. You don't want to spray your fruit with a contact insecticide.
And when you see both of those, would you try putting a trap across, like away from the area to try to pull them off? Or is the trap not really going to help at that point?
That's a great question. Based on the studies and what we've seen is once the Japanese beetles are feeding on a plant, a rose, or feeding on the fruit, the traps really are not going to be effective. They have to be applied early before they're there. And working with some of the fruit tree growers in Kansas and some of the vegetable growers, we put them about half a mile away and to lure them away from the area. But once they start damaging or feeding on an apple, they're going to stay there and feed. Yeah, the traps become less of a choice to them because they're getting nutrition with the apple as opposed to nothing when they go to the trap. Yeah. Any other questions? Yes, ma'am.
I don't know if I can ask you this or not. It's not about these. It's
Well, it doesn't
about-
matter. We can talk about anything.
It's about cedar apple rust.
That's a disease.
We had our bloom yesterday, and I was just wondering, is there anything that we can do before it blooms?
You mean the gelatinous?
Gelatinous, yes.
Yeah. Now remember, cedar apple rust is a two-host disease. It requires crabapple and juniper. So whenever you see those tentacle-like orange, yellow things, that's the stage on the juniper or the cedar, and then the other stage will be on the crab apples. It's too late to do anything at this point. Yeah.
But I mean, is there anything, any time of year, is there anything you can spray before that happens?
Early on, you can spray with a protectant or a contact fungicide early on the year to protect your trees. Especially, but you got to spray like the crab apples. But you can contact our plant pathology department, and they probably will have somebody. I know they should have somebody there to help you in terms of dealing with. There might even be extension publication on dealing with cedar apple rust.
Okay, thank you.
Yeah, good question. Anything else? Okay, so I will leave hard copies of these if you want them. And the Riker mount, does anybody know where that Riker mount was that I had? Thank you, sir. And I'll be around for questions. So are there any last minute questions before you go out in hot and humid day here on May 6th? Well, thanks for being here. I hope you have a good day, and maybe see you on May 20th. I'll be talking about honeybees and beekeepers. Hope to see you there, and enjoy the rest of the day.